Okay, this video is going to be about the diatomic gases. We're going to talk about what they are, and then we're going to talk about what they would look like if we could actually zoom in and see the atoms and molecules that make stuff up. Okay, so there are about 100 elements on the periodic table. And of those 100 elements, 7 of them are the diatomic elements. These are the diatomic elements here, and at the end of the video, I'll teach you some memory tricks so that you can remember which of the elements are diatomic. But anyway, what makes the diatomic elements special is that we never find a single atom, just one atom, of any of these guys on its own. Okay? So you never find just an oxygen atom hanging out, or a nitrogen atom, or an iodine atom. Instead, these atoms always pair up. You always find 2 of them together, connected together, forming a molecule. Let me show you what I mean. I'm going to draw some diagrams, and I'm going to put this thing up here, abbreviations of all of the different diatomic elements, just so you can remember which elements are diatomic and which aren't. Okay, so let's take 2 things that have gas in them. Here is a tank of oxygen gas. I stole this from my grandmother's nursing home. I was like, hey grandma, can I borrow your oxygen tank for a minute? And then I went to a kid's birthday party and I stole a helium balloon from the clown. Okay, so here's what I want to do. I want to put on my superhero glasses that allow me to not only look through the shell of this tank, but let me zoom in trillions and trillions of times and actually see the atoms that make up this oxygen gas. Here is what I'm going to see. Here's my enlarged view. Now remember that oxygen gas is there's an O up here. This is one of the diatomic elements. So this is what I'm going to see. I'm going to see that the oxygen gas is made up of oxygen atoms. You know, that's not a big deal. But I'm going to see that all of the oxygen atoms in the gas are connected to each other in pairs, just like this. They're connected in pairs, forming molecules. On the other hand, let's look at helium. Helium is not one of the diatomic elements. And so if I put on my superhero magnifying glasses and look at the helium balloon, I'll also see atoms that make up the helium. But here, He, He, these atoms are individual. They're on their own because helium is not a diatomic gas. I should also point out that I'm talking about gases here. All of the diatomic elements are gases at room temperature. So we always usually talk about gases when we're talking about diatomic elements. Okay, diatomic elements pair up, non-diatomic elements don't. Here's also what's important about this, though. The fact that these guys pair up influences how we write the name of oxygen gas. So if someone asks you to write the name of the chemical formula for oxygen gas, it's O2, because each piece of oxygen gas is 2 oxygen atoms connected together forming a molecule. So O2 for oxygen gas. But on the other hand, someone says, write the chemical formula for the gas, for the helium gas that's in the balloon, it's just He. It's not He2 or anything, it's just He. And that's because the helium atoms are by themselves, one at a time in helium. Just to give you 2 more examples, particularly of the writing of the chemical formulas here. I got a hydrogen balloon. You can also put hydrogen in a balloon. And then I've got a light bulb that has argon in it. Argon is a gas that's in light bulbs. And here is what the hydrogen would look like if I could zoom in on it. Look here that hydrogen is one of the diatomic elements, whereas argon, which is not a diatomic element, the atoms would be on their own. Going back to that idea of how we write the chemical formulas of stuff that's made up of diatomic elements, hydrogen, someone says write the chemical equation or the chemical symbol for hydrogen gas, it's H2, whereas argon is just Ar. So whether or not something is diatomic influences how we write the name of the chemical. So it's important to remember which of the elements are diatomic and which aren't. So how can you do that? There are a couple ways. Here's what I like to do. I like to take the symbol of each of the elements and write it out like it's a letter or group of letters in a word. And if I do it in this order, I come up with a word that sounds sort of like Brinkelhoff. It's a good way, like that's how I remember it. But there are many other ways you could arrange the letters that make up the symbols of these gases. So, you know, you could probably come up with plenty of variations on your own, maybe a word that would better stick in your head. So you can use Brinkelhoff, or you can come up with one on your own. Here's another way that you can remember them. Some people, instead of using the chemical symbols as letters, like to remember a phrase. And this one gets used a lot. People say, have no fear of ice cold beer. We want to talk about the letters that are in each of these words. We have H for hydrogen, N for nitrogen, F for fluorine, O for oxygen, I for iodine. It gets a little bit tricky with these last 2, which is actually why I prefer Brinkelhoff. But anyway, cold. Don't be confused and think that the C stands for carbon. It's Cl, chlorine, and then B, and the R at the end of beer, the R at the end of beer, is bromine. So you can think of Brinkelhoff, or another way to arrange these guys to come up with a word, or have no fear of ice cold beer. Hey, you can probably also come up with another phrase yourself that you like even more than this. Okay, so that's how to remember them. Now, if you're interested, I'm going to take just a minute. I'm going to talk about why these diatomic elements actually pair up. Okay, here's the reason why. The reason why is that on their own, the diatomic elements are sad atoms. They're unhappy atoms because none of them have a full valence shell of electrons. Here I've drawn electron dot diagrams of each one of the atoms. Remember that most atoms want to have 8 electrons in their outer, in their valence shell. None of these guys have 8. Hydrogen would be happy if it had 2, but it only has 1, so it's unhappy too. All of these want to increase the number of electrons that they have in their outer shell so they can have 8, or in hydrogen's case, so they can have 2. So let me talk about a big question that a lot of people have with the diatomic elements. These are the diatomic elements here. There's 7 of them, and they're bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Now, the diatomic elements are special because you never find just one atom of a diatomic element on its own. You always find them in pairs, okay? So you get Br2, I2, N2, and so forth. The big idea here is, say, for oxygen gas. You never find just one oxygen atom floating around. You always find it paired up with another oxygen atom, making a molecule with 2 oxygen atoms, and that's O2, and that's what's floating around. Okay, so after you learn about the diatomic elements, it can be kind of confusing when you run into formulas for chemical compounds like these. Okay, all of these formulas contain diatomic elements, but there's only one atom of them. Okay, so here we have one oxygen atom, one chlorine atom, one nitrogen atom, one bromine atom. So can you see why this is kind of confusing? Because here they're in pairs, and here they're individual. Let me show you some comments I've gotten on my videos that express this confusion. Okay, one person asks, how can H2O only have one oxygen atom? I thought oxygen was a diatomic element, so you can't just have one. You always have to have 2. Okay? Now talking about LiBr here, someone else asks, wait, shouldn't it be LiBr2? Because bromine is diatomic, so the atoms always need to come in pairs. So what's going on here? How come the diatomic elements, we say they have to come in pairs, and then we write all these formulas where we only have one atom of a diatomic element? These are great questions. Let's talk about this. So here's a big thing that sometimes is like the missing piece for people's understanding with the diatomic elements. Atoms of diatomic elements only need to pair up if they're on their own and not connected to any other elements. Okay, so let me show you what I mean. Let's take nitrogen gas. Nitrogen gas is made of only nitrogen. So if we took a little sample of nitrogen gas and we zoomed in zillions and zillions of times to be able to see the atoms that make up nitrogen gas, we'd see that the atoms are connected together in pairs of 2. Okay? This is what nitrogen gas would look like. This is what the atoms in nitrogen gas look like. We've got only nitrogen here. The nitrogen atoms are paired up. If we look at nitrogen gas, we would not see something like this, where the nitrogen atoms would be floating around individually. Okay? The same is true for liquid bromine, which is made of only bromine. We zoom in on a tiny little drop of liquid bromine, and it looks like this. The Br atoms are connected together in pairs. It would not look like this with the Br atoms individual. Nitrogen and bromine have to pair up because these contain, nitrogen gas, liquid bromine, contain only this element. There's just nitrogen here, there's just bromine here, so the atoms have to pair up. But if diatomic elements are connected to other elements, they don't need to pair up, right? So that's how we can have H2O with just one oxygen atom, because this O, it's not connected just to another O, but it's connected to 2 hydrogens. That's totally fine. This chlorine here, we can have one of it because it's connected not just to chlorine, but to sodium as well, and that's true with these other ones. So the big deal with the diatomic elements, don't forget this, is that they only need to pair up if they're only connected to each other, all right? 2 nitrogens have to pair up, 2 bromines have to pair up. But if they're connecting to other elements, they don't need to be in pairs. So all of these chemical formulas are totally fine. If there's another element in there, don't worry about the pairing, only if that element is on its own.